So we've got a binomial random variable here, and we're asked to use an approximation in order to find these probabilities. If you weren't given what the normal approximation would be, then you could find 72 and 6.12 squared by using our formulas that we learned before. Remember, n in our formula stands for the number of trials in the binomial distribution, and p stands for the probability of success in the binomial distribution. So we know that we could approximate it to y with the normal distribution, and the mean would be np, and the variance would be np 1 minus p. So in this case, the mean of the normal distribution, we would do 150 multiplied by 0.48, and you do indeed get 72. And the variance, sigma squared, which is this thing here, this number in this parameter here, would be 150 times 0.48 times 0.52. And if you actually work that out, the variance of the normal distribution would be 37.44. Well, notice that they've actually written this in the form that's really common, the standard deviation squared. So they've square rooted this, and they've said that that's actually equal to 1.26 squared. So the standard deviation is 6.12, and the variance is 37.44. Now, the reason why they've given it to you in this form, standard deviation squared, is because your calculator takes the standard deviation, not the variance. So because n is large and p is close to 0.5, you can see that I can draw a red line around my bar chart, which shows the binomial distribution, and it looks like a good approximation to the normal distribution. So actually, we're going to start by looking at, rather than this one, which is a little bit more complicated, let's look at a slightly simpler one. Let's look at the probability of x equaling 70. Probability that x equals 70. So I've just zoomed in on this bar chart onto the bar around 70, and this is what the chart looks like. So remember, what we're doing is we're drawing a normal curve over the top of these bars, this normal curve that we've been given here, and we're going to try and use this curve, the area underneath this curve, to find what's the probability of x being 70. So the probability of x being 70 is the height of this bar, and that's equivalent to drawing a rectangle around 70, going above by 0.5 and below by 0.5. And that's to ensure that the width of the 70 bar is 1, to make sure that when we work out the area of this bar, we do get the probability of x being 70, because it'll be 1 times by the probability of x being 70. So we know that we're going to approximate this area, this green area here, by working out the area underneath the red curve between 69 and 75. So we're going to say that this is approximately equal to the probability of y being between 69.5 and 70.5, because that's just going to give us the area underneath the curve, the red curve, the normal curve. And it's important that we use y here, because y is our normal random variable. It's the red curve here. Now, what we don't really want to have to draw a bar chart like this each time. So instead, let's come up with a different way of showing this. What I actually do each time is I draw a little sketch of the normal distribution. And I know that 72 is in the middle. Now I want to work out the probability of x being 70. So I'm going to put 70 on my diagram. And I'm going to go below by 0.5, so 69.5. And I'm going to go above by 0.5. And I know that I'm going to work out this area here between 69.5 and 70.5. And I don't actually worry about the scale. I know obviously the scale's massively off. It's just to help me think about what I'm actually doing. I'm basically drawing this diagram to remind me of the fact that this 70 on the number line occupies 69.5 to 70.5 because of continuity correction. So we can work out what this probability is. We're going to go to our calculators and we're going to go to normal cumulative distribution, normal cumulative, and we're going to put our lower as 69.5 and our upper as 70.5. Our standard deviation is 6.12, that's this number here. Our mean is 72. So if we do that, we get 0.0617. Let's look at part A then. So we want the probability of x being less than or equal to 70. So I'm not going to draw out the bars this time, I'm just going to draw out the normal distribution curve. So we know for our normal random variable, y, we know that we've got 72 as the mean, which is in the middle. Now we want the probability of x being less than 70. So I'm going to put 70 on my diagram, and I'm going to go above by 0.5, and I'm going to go below by 0.5. Now we want x being less than or equal to 70. So that would mean basically we want to work out everything to the left and including this green bar that we did here. So that means we want to include 70. Now 70 occupies the space on our number line from 69.5 to 70.5. So we need to include everything to the left of 70.5 to make sure that we include 70 in our area that we're going to work out. So that's going to be approximately equal to, so let's write this down, probability of x being less than or equal to 70 is approximately equal to the probability of y being less than 70.5. So we can work out what that probability is using our calculators. So we're going to put our lower as minus infinity, so minus 9999. And our upper, we're doing the area up to 70.5. We're going to put our standard deviation is 6.12, and our mean was 72 of our normal distribution. And we get that as 0.403. And we could do a similar thing for B, if we sketch out our normal distribution again, just to help us think about what's going on. So I'm going to put on 80 on my diagram. And I'm going to go 0.5 below and 0.5 above. So we've got 79.5 and 80.5. And I'm going to put 90 on my diagram as well. So we've got 90 somewhere, and I'm going to go 0.5 above and 0.5 below. Now we want to include 80 because x is greater than or equal to 80, but not include 90. So to include the 80, we're going to have to start at 79.5 because the whole of the 80 bar would have been occupied by 79.5 to 90.5. And then we're going to go all the way up to, now we don't want to include 90. The 90, when we do the continuity correction, would be from 89.5 to 90.5 on the number line. So we don't want to include any of that bar. So we're just going to go up to 89.5. when we've done our continuity correction. So the probability of x being greater or equal to 80 but less than 90 is approximately equal to the probability of y being, so our normal random variable, being greater than 79.5 but less than 89.5. And it doesn't matter whether you put a strict or not strict inequality, so you could have put or equal to on either of these inequalities. It doesn't make a difference. So we're going to go to our calculator and just change the lower to 79.5 and the upper to 89.5. And we'd get 0.108.